Hello and welcome to our lecture once again. My name is Miracle Chibuzo Marcel, and today we are going to be learning about comets. Comets are regarded as ancient wanderers, okay, ancient wanderers from our solar system or from other star systems. So we're going to be learning about comets today. So as a gentle reminder, this lecture is sponsored by the Free Astro Science Group. So when I was much younger, I learned most of my knowledge about astronomy were through listening to people, listening to people that are probably experts on watching television, watching reading all kinds of books. So that is how most of my early knowledge of astronomy started. So I listened to one popular person in my childhood, and he said that there are stars with hairs. So there are stars with hairs. They have faces like humans. They have eyes. They have nose, and they have mouth. I mean stars, white in color, and they have hairs, and they roam about like fish in the heavens. And I was really stunned, to hear that, and because I've never imagined that kind of thing. So I realized that he was talking about comets. Okay, so so I want to know, was that actually true? Because that actually motivated me to want to study astronomy the more, okay, and to pay more attention to astronomy, because there are a lot of concepts in astronomy that people misunderstand. So that is why I want to talk about comets today. What really are comets? So at the end of this lesson, learners should be able to understand what a comet is and explain its basic compositions and differentiate between the two main reservoirs of comets in our solar systems. There are two reservoirs of comets in our solar system. So at the end of this lecture, you should be able to differentiate between the two. Okay, you should be able to understand them and differentiate between the two. Then you should be able to explain the difference between short period and long period comets and identify and describe the two types of comet tails we have. We have two comet tails, but most people see only one. So we are going to understand and differentiate the two, identify and describe the two of them, then explain what interstellar comets are. You Last year you probably heard about three comets from other star systems. Okay, what does interstellar comet mean? So I'm going to be explaining them in this lecture, and so many other things, so many other processes that happen in a comet. So as part of the introduction, when people hear about the word comet, okay, they imagine a bright object with a long glowing tail, okay, suddenly appearing in the night sky. Okay, so there's a comet there. Okay, so but since history and even in popular cultures, comets are often seen as mysterious signs in the sky. Okay, some people see it as a symbol of a forthcoming disaster. Okay, some people see it as messages from the gods. Okay, so there are a lot of meanings attributed to comets. You understand? But even today, many people think comets are as rare, unpredictable, or dangerous object that appears without warning. And even some people, attribute some you know, astrological, they attribute astrological meanings to it. You understand? But in reality, comets are not stars with comets are not stars with hairs, like I described before. I heard from someone. They're not stars with hairs. Comets are natural members of our solar system. They are natural members of our solar system. Okay, and we can predict their path well. We know where they are coming from. Okay, we know what they are. Just like we have, as part of our, as members of our solar system that you know about the sun, you know about the planets, you probably know about asteroids. Now, comets are natural members of our solar system. Now, so what is a comet? So a comet is simply an icy small solar system body or interstellar object that warms and begins to release gases when passing close to the sun, a process called outgassing. So three things are important here: icy, icy, icy small solar system body, and icy interstellar objects, because we do have comets that are coming that originate from our solar system, and we have comets that originate from other stars, and they are both icy. Okay, in astronomy, whenever you hear about ice, okay, don't quickly think about water ice. Okay, ice, you have to think in generic form. In generic form, okay, ice does not only mean water ice. Like if you have gas that is frozen, can also be can also be icy. Can also describe it as icy. Cannot so don't always think icy in terms of water ice. So anything icy can be gas. It can be any liquid. It can be any gas that is frozen. Okay. So when it comes to comet ice is a comet. Comet, as an icy body, is a frozen mixture of water, okay, water, gases like carbon dioxide, carbon two oxide, okay, ammonia, methane, then all of them mixed with dust and organic materials. So a comet is a mixture of so many liquids and gases and dirty dust, organic materials. So that is why comet is referred to as a dirty snowball. So you can imagine it as a dirty snowball. So why do comets become bright and glow tails? So are they naturally like that? Are comets naturally uh, are they naturally bright, and do they have those tails naturally? No, they do not. So there's a process that they undergo that makes them to become bright and to grow tails. And we are going to understand that. I'm going to use this picture to describe it. So first of all, as a comet approaches the inner solar system, okay, as a comet is approaching the sun, okay, because the sun is at the center. Okay, the sun is the center of gravity of the solar system. Okay, so as a comet approaches the inner solar system, so the heat from the sun, causes the ice inside the comet to sublimate. So sublimation is the process by which uh, solid materials change directly to gas without going through liquid form. Okay, so comets behave that way. So as they approaching the sun, the heat from the sun warms them up and they begin to sublimate. So you can see the picture here. It is coming closer, moving towards the sun. This is an AI generated image, so just to describe it. So as the sun's heat heats it up and begins to sublimate. So that's just the first two processes that I've just described. So, but this escaping gas carries dust with it, forming a glowing cloud around the comet called the coma. So as the escaping gas is going out, it is also carrying dust with it, and both of them form the coma. So here is the glowing coma. Okay. Now I'm going to come back to this. Okay, for why this happens later. So at the same time, the sunlight and the solar wind. Sunlight is the photons, while the solar wind is the ions. Solar wind, the ions that are coming out from the sun, they push the gas and dust that are emanating from the comets away from the comets. So as they are pushing them away, there is this long, beautiful tail that is being created. So this is why comets, that is why comets grow bigger. I mean, as they approaching the sun, the tail become longer and brighter. So that is why they become bright and grow tail. So here is the picture of it. So there are two tails here. This is the dust tail. This is the iron tail. Although the labels were not perfectly aligned because this is an AI generated image to describe what I wanted to describe. But that is just the process. Now, there are I mentioned something very important here, okay? So, and I want you to understand something here. So, as the comet approaches the sun, okay, the gas and dust are ejected from the surface. So, as gas and dust are ejected from the surface, that will give you that is giving something that happens with Newton's law. Okay, the Newton's third law. Okay, Newton's third law. It says action and reaction. Okay, so that is what happens to a balloon. If you release a balloon, air immediately rushes out and it gives it a forward motion. So it gives it a force. So now that outgassing uh, materials, the outgassing process produces a reaction force, a very weak reaction force. So that it gives it an acceleration. We call it non-gravitational acceleration. So there's an extra force that is acting upon a comet in addition to the gravitational force. Okay, and that extra force, uh, that is why it is many people are getting confused whenever we see comets. We see that the force acting on it are not just only gravity, there are other extra forces. Some people mistake it as maybe aliens or alien ships. They're not alien ships. Those forces are from those outgassing, those gases that are being released from the surface of the comet. So now, this is how it affects the motion. This is how the outgassing force affects the motion of the comets. So the thrust is very small compared to the gravity from the sun and the planet. Okay, so it does not dra- dra- dramatically change the comet's orbit. However, over time, this light force can slightly shift the comet's trajectory. So assuming that you think it's coming, okay, it's going to be here in the next few minutes, it will just change. Okay, it makes you feel like, oh, this is an alien ship. It's not an alien ship. Okay, so and it also changes the timing of the perihelion passage and makes the orbital prediction less accurate. So now, why do we care about this outgassing acceleration, this non-gravitational acceleration? And the reason why we are concerned about this little force is because it's we when we include it in our model, when we create the the model of a comet, and we add this extra force, this non-gravitational force, it enables us to predict the orbit very accurately. And also, sometimes we send spacecraft on a comet, okay? So to be able to predict where it's going to be at any moment in time, we should, add these little forces to be able to predict what it's going to be. Or else, if you set a spacecraft to collect samples of comet, the vision might become not unsuccessful. So that is why we add these forces. So where does comets come from? So there are two places comets come from. There are comets that come from our solar systems, and there are comets that come from other solar systems. So let us see the comets that come from our solar systems. So this is a video. I want to play this simulation. So, remember, after the sun and the planet were formed about 4.6 billion years ago, not all the materials were used up. Okay, not all the materials were used to form planets and asteroids. Okay, some of the materials, some of these leftovers were icy, and due to gravitational perturbations, they were pushed outwards. So they settled into reserves in our solar systems. So those reserves became the birthplaces of these comets. And I'm going to explain these two reservoirs. So the first of them is the Kuiper Belt. Probably have heard about it, the Kuiper Belt. So this Kuiper Belt is a wide disc-shaped region beyond the orbit of Neptune. Okay, just immediately after the orbit of Neptune, you can see the Kuiper Belt continues. It continues on and on, a very wide, disc-shaped region. Okay, so this region is filled with icy bodies, which are these remnants from the early solar systems after the formation of the solar systems. So you can see the picture here of what I'm talking about. So these are icy bodies that are here. So they are the ones that form the comets. Now, comets that come from the Kuiper Belt are called short period comets. And the reason why they are called short period comets is because it takes them less than 200 years to orbit the sun. It takes them 200 years to orbit the sun. Like for instance, some comets can take them 80 years, 70 years, 50 years, 100 years, 150 years. So, but any number less than any number less than 200 years. So, all those comets are regarded as short period comets. And one feature about them is that they return again and again in our lifetime. Okay? In our lifetime. So, and they also follow a relatively predictable path. So they follow a relatively predictable path. So one of the famous example is the Halley's Comet. Okay, it returns every 76 years. So you can see the simulation right here. So here is another. Um, Here is the Halley Comet. Okay, so this is the orbit of Neptune, and this is the orbit of the Halley Comet. The orbit takes it away and into that Kuiper Belt, and it returns every 76 years. Then we have the Oort cloud. So now, far beyond the Kuiper Belt, far beyond the Kuiper Belt lies a much more distant and mysterious region called the Oort cloud. Okay, so this Oort cloud is not a disk. Okay, but it is a huge spherical shell surrounding the solar system. So imagine it as a ball, a spherical shell, okay, surrounding the solar system. Okay, and it extends even halfway to the next star, you know, the the closest star to our sun. So that is it. So you can imagine how far it extends. So here from this picture, you can see, from the what we talked about from the Kuiper belt, from this one. This is the orbit of Neptune. So here is this picture. This is Neptune. This is the edge of Neptune. And here is the edge of the Kuiper belt that we just talked about. And that's the sun there. Now, if you imagine a particular comet from this Oort cloud, maybe you can imagine this one. You can see that the orbit takes it farther away from the sun to this Oort cloud. Then it comes back. So what is making them to come this close? What is making them? I mean, if something is this far away from the sun, what will ever make it to come close to the sun? So there are many forces at play, but it comes close to the sun. It this comet can go halfway between the sun and another star, but it will still come back. So it is bound to the sun. It is bound. So we call these comets we call them long period comets because they take thousands or even million years to return or to orbit the sun. And so they appear just once in human lifetime. But another important thing, unlike short period comets, the ones that come from the Kuiper belt, these comets from the Oort cloud can appear from any direction. There's no particular direction. So, how does comet or how do comets from our solar system get pushed towards the sun? How do they get pushed towards the sun? It's an important question. Okay, so you know, no object in the no object in the solar system has an engine of its own that gives it a force. So it means that they all depend on gravity. Gravity from different sources. So it is gravity that nudges them, that pushes them, that moves them. So their motion is predicted by gravity and other forces that are controlling them. So for the comets, number one force for comets is the sun because the sun is at the center. It is massive. It contains 90. The sun is about 99% of the mass of our solar system. So uh, most of the forces that control the planets, the comets, and asteroids are coming from the sun. Then we have passing stars. Okay, forces from the passing stars can disrupt the arrangement of these Oort clouds. Okay, the arrangement because they are separated, like they are separate. Okay, they are like shells, like a Dyson sphere. So nothing is holding the object together. They're just like dust. So whenever there's a passing star, okay, the gravity from that passing star can disrupt the arrangement of these icy bodies, and that can direct some of these comets to start coming towards the sun. Then we have gravitational pull from our Milky Way galaxy. So gravitational pull from all the stars in our Milky Way galaxy. So the resultant force, if it's in the direction of our sun, is going to disrupt it. And we have even the force from Jupiter. Jupiter is the largest and the heaviest planet in our solar system. So they influence the motion of most uh, Kuiper belt Kuiper belt comets. So this this Jupiter, it can send the comet towards the sun. It can change the orbit. It can even send them away from the sun. So that is why Jupiter is regarded as the protector or the disturber of the comets. Or it can even do that to asteroids. Now let's talk about interstellar comets. Now, not all the comets are born in our solar system. Some of them originate from other solar systems. Remember, our sun is a star with planets, with asteroids, with comets. So all these other stars you see at night also have their planets, they also have their asteroids, and they also have their comets. We call them debris disks. Okay, so they too the force, any force that is acting between these stars can send some of these comets towards Earth, towards our own solar system. And when that happens, we call them interstellar interstellar comets. But unlike our solar system comets, they are not bound to the sun. They follow hyperbolic path and they visit once and never return. So this picture, it's a simulation. So this is the expected trajectory, and this is the observed trajectory. And the reason why we have this is because of the outgassing force that I talked about. If you do not factor it in, it will be misled. Okay, if you do not factor it in, you might think the asteroid is going to pass through this direction. Okay, but it ends up passing through here. The reason is because the outgassing, this non-gravitational acceleration, wasn't factored in. So that is why it wasn't factored in. And so some people thought it was an alien spaceship. So if you could remember, Oumuamua, the rumor that went on about the Oumuamua, some people thought it was an alien spaceship because they failed to factor in these outgassing forces. The anatomy of a comet. Now, although comets can look huge and beautiful and dramatic in the sky, their solid core is actually very small. The real substance we call comet is actually very small, and most of what we see is not the comet itself, but the material escaping this little material, the small part. Okay, so let us study about the anatomy of a comet. So the first part of a comet, which is the most important part of a comet, is the nucleus. The f- the the nucleus. So at the center of every comet is called the nucleus, which is a solid object, okay, which is a solid part, usually a few kilometers across. Now this nucleus is made up of ice. You know what I mean by ice? I've talked about ice. Anytime you hear about ice in astronomy, we're talking about water, carbon dioxide, carbon monoxide, methane, ammonia, all of them together, mixed together. Then we have dust and we have rocky material. So the nucleus is made up of ice, dust, and rocky material. So here is this. From this diagram, you can see the nucleus of a a comet. So here's the nucleus of a comet. It's quite very small compared to the entire size, the physical size of the comet. Then we have the coma. We have the coma. So here is the coma. Coma is, uh, as a comet approaches the sun, the nucleus will begin to warm up. It will begin to sublimate. Remember what is sublimation? We've talked about that before. The nucleus is going to sublimate. That means turning directly to gas. Okay. So now this escaping gas drags dust with it, okay, and this forms a large glowing cloud around the nucleus called the coma. Now, there's some key points about this coma. This coma acts like a temporal atmosphere. It acts as a temporal atmosphere to the nucleus, okay? Now, this coma can grow larger than a planet, even though the nucleus is very tiny. And it grows because sunlight excites the gas and the dust, okay? And the coma only exists when the coma uh, is closer to the sun. So here is the coma, the white part here is the coma. Then we have the tail, which is the most visible part of comet. Now, where most people when most people see a comet, they only see one tail, okay? One long tail, one long beautiful tail. But comet actually have two different tails produced by two different physical processes. So here is the first one is the dust tail, and we have the ion tail, or can call it the gas tail. Now, the dust tail is made up of dust particles. So here's the dust tail. It is made up of dust particles. So dust is pushed away by sunlight pressure. Okay, it is pushed away by sunlight pressure, and because dust particles are heavier, they move more slowly, and this causes the dust tail to appear curved. So if you look at that, they appear curved compared to the gas tail. Okay, and they look yellowish or white in color, and they spread out like a fan. Now, for the ion tail, they look straight and sharp. Okay, they are made up of electrically charged gas particles called ions. That is what ions are called. They are created when solar UV rays ionizes the gas. Like solar wind, a stream of charged particles from the sun sweeps the gas away. And because the solar wind moves fast and directly outward, the iron tail is straight, often appears bluish, and points directly away from the sun. So here is the gas tail or the iron tail, and here is the dust tail. Now, there is something I want you to know about the comet's tail. A golden rule I want you to know about a comet tail. Anytime you see a comet, let me show you a comet. Look at this comet right now. You might be tempted to assume that it is heading, I mean, the sun is somewhere here, but it's not true. Or somewhere here, or somewhere here. How do you know the direction? How do you know? How do you know how a comet moves? Is that from its tail? A comet's tail always points away from the sun. Always points away from the sun, not behind the comet. Do you understand? Even when the comet is moving away from the sun, the tail still points outward. And so this is because the tail is controlled by sunlight and solar wind, not by the comet's direction of motion. So you can see that. So when they're coming closer, this is the orbit. So when they're coming closer, the gas tail is always pointing away from the sun. So and this is because it is controlled by sunlight and solar wind. So this always pointing away. Always look at this one, always pointing away. So look at that. So it is moving away from the sun, but it is look at the tail. It is always pointing away from the sun. So what are the importance of comets? Well, comets give us clue to planet formation, okay? Especially the water delivery to Earth. You know, we believe that the water we have on Earth came from the comets. Okay, it came from the comets, and not just only Earth, all the planets. You know, Mars. There's water on Mars, frozen water on Mars. There's also water on the Moon. In fact, most of the planets in our solar system, or even their moons, have some form of water, and we believe that those waters were delivered by the comets. They also we believe that life, the organic material, the molecule that gave rise to life, came from comets. Okay, there's a theory about that, and also they give us clue to, uh, uh, I mean, they give us samples to other planetary systems. So imagine a comet from another planet, visiting our solar system. We can, if we arrange properly to send, uh, to send a probe to it, can collect samples from that, and that to give us clue to to you know exoplanets and other worlds, other solar systems. Now, how about famous comets and interstellar visitors? So within our solar system, some of the famous comets that have visited our solar systems are the Neowise comet. Neowise, you heard about it in 2020, and we have Halley comet. I've mentioned about that. So look at the trajectory. Their trajectory is very predictable. Okay, it's very predictable. They do not come from any direction, so the orbits are predictable. Then we have interstellar comets. So we have the Oumuamua. So we have first, that is one eye. One eye means the first. Number one, interstellar. One eye means one interstellar. Okay. So then we have Oumuamua. It came around in 2017. And here's the trajectory. Now we have the two eye. That means second interstellar. It's Borisov in 2019. Came around. So that the yellow line is the trajectory of that comet. It's yellow line. The red one is for the Oumuamua. This simulation is just trying to compare the trajectory of the Oumuamua and this one. Okay. So then we have the three-eye atlas that appeared last year. So here is the three-eye atlas. That is the motion of the three-eye atlas comet. We even captured it with our telescopes. So thank you so much for your time.